Okay, class, we are starting 3.6, Model Direct Variation. It is in your book on page 191. We have two vocabulary of the day words today. The first would be direct variation, which is defined as the ratio is the same for any pair of coordinate points in a set of pairs. So if y divided by x is the same for all coordinate points, it is direct variation. And another way of thinking about this is if your equation is in y equals mx plus b format, then we have y equals mx. There is no y-intercept, or in other words, the y-intercept is 0. Constant of variation, that is your slope, okay? It is that coefficient of the x variable. So again, and I think everybody got this down, but if we have y equals mx plus b, okay, b has to equal 0. For our constant, it's that coefficient of x, or the slope. So moving on, we have one goal today, and that is to write and graph direct variation equations. Write and graph direct variation equations. In your books, page 191 are the definitions, okay? I've also once again included my words, so if you didn't get those notes earlier, by all means get them now. If you take a look in your book with example 1, and this is on the bottom of page 191 for you, the directions read, tell whether the equation represents direct variation. If so, identify the constant. So up here, I've put a little reminder. I'll move my thing here so you can read it. Remember to always write in slope-intercept form. Y equals mx plus b is what we're looking for. Negative x plus y equals 1. How do I get negative x to the other side? Opposite of negative x is positive x. So I have y equals x plus 1. Is this direct variation? Well, our y-intercept isn't 0, so the answer is not direct variation. And that is what you need to add at the bottom for your final answer. Moving on, example 2, same directions. I have 2x plus y equals 0. My goal, what I'm looking for is y equals mx plus b. So I need to get 2x to the other side. The opposite of positive 2x is minus 2x. So I would end up with y equals negative 2x. There is no y-intercept. In other words, the y-intercept is considered to be 0. So in this case, it is direct variation. And my constant of variation, which is represented with a k, would be negative 2. I always like to write it as a fraction. Your choice, negative 2. So next example, we have 4x minus 5y equals 0. Again, my goal, y equals mx plus b. How do I get 4x to the other side? The opposite of positive 4x is negative 4x. Negative 5y equals negative 4x. Divide both sides by negative 5. Recalling that a negative divided by a negative is a positive, we have y equals 4/5 x. There is no y-intercept. My y-intercept is 0 in this case, so it is direct variation. My constant of direct variation would be 4/5. Again, k represents the constant of variation. And finally, it says graph the direct variation equation. So the first thing we need are our x and y axes. Here's my x running horizontally and my y running vertically. So y equals 2x. I know it's direct variation. It tells me it's direct variation. Because it tells me it's direct variation, I know this point, the origin, 0.00, has to be on there. Okay, from there, y equals mx plus b. Y equals 2x. My slope is 2 over 1. And again, y-intercept, just for the fun of it, is 0, because with nothing here, it means plus 0. Using my slope of 2 over 1, remembering once again, I can't write this often or say it often enough. Rise over run. Run goes left to right. Rise goes up and down. So that means starting at point 0, I'm walking 1 step over and 2 steps up. 1 step over, and 2 steps up. I could also walk this way, 1 step to the left and 2 steps down. Still going to give me my positive slope. So when I go to graph the line here, connecting my dots, I have now graphed the direct variation equation.